Good morning, dear students. A warm welcome to all of you for our today's online session for the subject Science and Technology Section A. In our previous session, we have started with chapter number 3 from Section A, that is Current Electricity. The topics which we have covered in our last session are Introduction to Electricity, Potential and potential difference of a cell, and about current flowing through a wire due to the movement of electrons. Topics which will be covered for today are more about electric current, resistance and resistivity, system of resistors and effective resistance. So let us first have a glance in the first 5 minutes at the topics which we have covered in our previous session. That is, we will just revise quickly and then we will start with our today's topic. We had seen how electricity plays an important role in our daily life. The first topic was potential and potential difference, which we had studied with the help of a small demonstrative activity where two plastic bottles were kept, one at a higher height and the other at a slightly lower height. Both of them were connected via a rubber tube and it was clamped in between. As soon as the clamp was removed, the water which was present in the first plastic bottle, it started flowing in the bottle which was at a lower height, and it stopped flowing when the level of water became same in both these bottles. And here we studied our first concept related to electricity. The flow of electric charge between 2 points also depends on a kind of electric level at those points, and this level is called as electric potential. Means just like the water flow which we have seen in this experiment, the flow of electric charge is also same like the flow of water, and it depends also on a kind of electric level which was known as electric potential. Our next concept was that is potential difference and the flow of electricity. So here the very first concept which we had studied is that the flow of positive charge is from a point of higher potential to a point of lower potential, and electrons being negatively charged. We are going to see later how the flow of electrons are necessary for the production of electricity. So these electrons being negatively charged, they flow from the point of lower potential to a point of higher potential. Here we had seen a small, you can see activity over here. Here there is a positively charged conductor and a negatively charged conductor. Conductor, I have told you in the beginning, is nothing but a wire. Why it is called as conductor then? Because it conducts. It allows the flow of current to flow through it, and hence it is called as conductor. Now here in this figure you can see conductor A is at a higher potential than conductor B, and when both of these are connected by a conducting wire, you can see a potential difference is created between its two ends, and from where the electrons will start flowing, it will start flowing from B to point A. Why? Because electrons are negatively charged, and this flow will continue till you can say both the conductors, that is A and B, have the same potential. Means in scientific terms you can say that when their potential difference becomes zero, and only then the flow of electrons from B to A is going to stop. So here you can say that work has to be done against the electric field to take a positive charge from a point of lower potential to a point of higher potential, and hence we are going to study the next concept related to it, potential difference of a cell. Now the difference in potential that is electric potential we are speaking about, between the positive and negative terminals of a cell is nothing but the potential difference of the cell. Now, this potential difference, as I have told you earlier, it is created by the chemical reactions which are occurring inside the cell. And this is the potential difference which sets the negatively charged electrons in motion and results in the flow of electricity through a conducting wire. Flow of electrons is necessary for the production of electricity. Remember this. So, what is the formula for potential difference? Work done in carrying the electric charge from point A to point B, that is from a positive to a negative terminal. So, work upon total charge transferred. Potential difference can be indicated by a capital V. V is equal to W upon charge as Q. And when you can say that potential difference is 1 volt, when 1 joule of work is done in moving a charge of 1 coulomb from one point to another. And why V? Because the unit of potential difference, its SI unit is volt. And why volt? That also I had explained you last time. The Italian scientist Alessandro Volta, he had constructed the first electric cell, and hence the SI unit of potential difference is a recognition of his work. And so from his surname Volta, the SI unit is given as volt. Now, also we had studied last time the conversions, as you have seen the conversions in maths, kilograms into grams. So similarly here, small values of potential difference and large values of potential difference. Small values means in your domestic appliances and all which you use in your house, and large values for industrial purposes. So 1 millivolt is equal to 10 raised to minus 3 volt. 1 microvolt is equal to 10 raised to minus 6 volts. 1 kilovolt is, here this minus sign only will go away, 10 raised to 3 volts. Megavolt is equal to 10 raised to 6 volts. After that, we had studied about the current flowing through a wire by taking up a small picture about the motion of electrons. There we had seen that if the conducting wire is not connected to a cell, then its free electrons are in a state of rest. Means not in a state of rest, you can say they are moving randomly here and there. They are not under any control. So in a metallic wire, in every atom of a metallic conductor or a wire, it has one or more outermost electrons. And where are these electrons moving? They are moving around the center of the atom, that is the nucleus. And they move randomly, and hence they are called as free electrons. So here you can see in the first picture the random motion of electrons when the conducting wire is not connected to a cell. As soon as we connect the ends of the wire to the two terminals of a cell, what happens? Here the electric force, you can see the wire is connected to the two ends of a cell. The electric force, it starts acting on these free electrons, and as they are negatively charged, where they will move? They will start moving from, you can see the arrow, from the negative to the positive terminal of the cell. And due to the flow of these electrons, current starts to flow through the wire, and thus we can conclude here that flow of electrons generates current in the wire. Keep this firmly registered in your brain, that electrons flow means current will be generated in the wire, because next year in the 10th standard you are having chapter number 4 where you are going to deal with this topic of electric current. Now from the beginning we are speaking about current, electricity, current. So what is this current in scientific terms? That we are going to study in our next topic. So this is the topic which we are going to start today. More introduction about electric current. Now, just now we have seen that electric current is nothing but the flow of electrons through a wire. So how you can define current? Current is denoted by capital I. Remember carefully, it is defined as the charge passing through a conductor in unit time. Charge, why? Because you know electrons carry negative charge. So in scientific terms we can say that current is the charge passing through a conductor in unit time. So if charge Q, charge is denoted by Q, we have seen in potential difference, is flowing through the cross section of a conductor in time t, then current I will be equal to charge flowing in a particular time. So the formula for current is I is equal to Q upon T. Remember all these things because this formula is not only important for you to study, but it is extremely important for you in solving the numerical examples based on this topic. One solved example we are going to see in our next slide. Now we are going to see what is the unit of this charge, what is the unit of this current. So the SI unit of charge is coulomb, that is capital C. So when you are going to denote about electric charge, it will be in coulombs, that is capital C, and current is expressed in ampere. Now why ampere, I will show you in the next slide. It is also in honor of one of the French mathematician, Andrew Ampere. So when you can say that the current flowing is 1 ampere, 1 ampere current is said to flow in a wire if 1 coulomb of charge flows through it in 1 second, that is every second. So 1 ampere is equal to 1 coulomb upon 1 second. So this part purposely I have displayed here on the slide because this thing should be learnt by you. Here there is nothing application based, only this formula and all you are going to apply in solving the sums. So remember, current is nothing but the flow of charge through a wire. So it is formula is I is equal to Q upon T, current denoted by I, charge denoted by Q, and time already you know small t. Unit of current is ampere, unit of charge is coulomb, and 1 ampere current is 1 coulomb flowing through a wire in 1 second. Now why ampere? You will come to know in the next slide. You can see here the photograph of a French mathematician who was also a scientist, Ampere, and he conducted a number of experiments regarding electricity in the field of electricity. Now today we can measure the amount of current flowing through a conductor through a wire only because of his effortless, you can say more and more efforts were taken in this field in his work, and then the unit of current is called ampere as a recognition of his work. Devotedly he was working in the field of electricity, and today whatever amount of current we are measuring in ampere is in honor of his work. One small thing here you have to remember is, even though electrons they move from negative to the positive end, conventionally the direction of current flow is taken to be opposite of the direction of electrons, that is from the positive to the negative terminal of a cell. This is very important line. We have seen that electrons are negatively charged in our previous slide, one slide before that, and I have told you that electrons being negatively charged, they will move from negative to positive end. Means now what will come in your mind? If electrons are moving from negative to positive end, then current flow will also be in the same direction? No. For conventional purpose, the direction of current flow, it is taken from the positive to the negative end, even if electrons flow in the opposite direction. And as we have seen the conversions for potential difference, same here 1 milliampere is equal to 10 raised to minus 3 ampere and 1 microampere is equal to 10 raised to minus 6 ampere. Now how you are going to remember all these conversions? When you are studying these conversions, you study in comparison with each other. You can see for potential difference it is 1 millivolt is equal to 10 raised to minus 3 volt. So here also you remember in mind whether it is millivolt or milliampere, it is 10 raised to minus 3 volt. Then you will write here volt. If it is ampere, here you will write ampere. There also you have seen 1 microvolt is 10 raised to minus 6 volt. So here also 1 microampere, same. Only in place of ampere, here you will write, for volt, you will write volt. If it is ampere, here you will write ampere. This conversion remains same. And what about the kilovolt and megavolt? Only this minus sign will go away. So it will be 10 raised to 3 and 10 raised to 6. So you don't have to remember much. If you you can say remember in comparison with each other. Now a small solved example. I have told you how that formula of electric current which you have studied, you apply in the sum that we are going to see in our next slide. This is a solved example from page number 33 of your textbook. The sum says a current of 0.4 amperes flows through a conductor, that is a wire, for 5 minutes. How much charge would have passed through the conductor? Amount of current is given, time is given. You have to find the amount of charge, that is Q. As usual, first you will write given current I. Now you know you have to show in denominations only. So I is 0.4 amperes. Time is in minutes, so that minutes you have to convert into seconds. So 1 minute is 60 seconds. So 5 multiplied by 60, 300 seconds. I you have, T you have to find the amount of charge. So Q. So what formula you are going to write? Q is equal to I into T. Just now you have studied the formula. I is equal to Q upon T. You want Q. So T will come here. It will become multiply by T. Substitute the values. In place of I, 0.4 amperes. In place of T, 300 seconds. When you multiply, you will get the answer 120. As it is the amount of charge, it will be in coulombs. So the amount of charge is 120 coulombs. So the charge passing through the conductor is 120 coulombs. From this numerical example, you understand how formula are used, how formula are applied in solving the sums. With this, we complete with the topic of electric current. Now we move to a very next topic, that is resistance and Ohm's law. Resistance and Ohm's law. Here this Ohm's law is extremely important in the field of electricity, and one experiment also we have in section A based on it. What does this Ohm's law state? The relationship between the current flowing through a wire and the potential difference across its ends can be obtained from the law that was given by the German scientist George Simon Ohm. Now this law states, if the physical state of a conductor remains constant, the current I flowing through it means through the wire, is directly proportional to the potential difference V between its two ends. Now when we speak about the physical state of a conductor, physical state means the length of the wire, the area of cross section, the temperature and the material of which the wire is made up of. If the physical state remains constant, then the current flowing is directly proportional to the potential difference. So I directly proportional to V. So if you want to remove this sign, we have to take some constant of proportionality. So I is equal to K multiplied by V, where K is the constant of proportionality. If you take this K over here, it will be I upon K. So that I have taken as I multiplied by 1 upon K is equal to V. 1 upon K is what? It is R, that is the resistance of the conductor. So I, now in place of 1 upon K, what you can take? R. So I multiplied by R is equal to V, or you can write V is equal to I multiplied by R is IR, or you can take R is equal to V. This I will come here, V upon I, and this is known as Ohm's law. So the resistance of the conductor, its unit is, SI unit is ohm, which is indicated by this symbol. So when you are going to solve the numerical examples, every time you will not write OHM ohm, you are going to denote it by using this symbol for ohm. So in short, what you can speak about the Ohm's law? As long as the physical state of the conductor remains constant, the potential difference V applied between the two ends is directly proportional to the current flowing through it. So remember this, ahead for sums. V is equal to IR, or R is equal to V upon I. Or if you want to get the value of I, then I is equal to V upon R. So this formula is important ahead. Now when we speak about resistance of the conductor, let us see what is resistance. Okay, before that, when you have to speak about 1 ohm, it is 1 volt potential difference upon 1 ampere current. And when you can say that the resistance is 1 ohm, when 1 ampere current flows through a wire, when 1 volt of potential difference is applied, then only the resistance of the conductor is 1 ohm. So this formula should be remembered by you. Resistance of a conductor. Here in this figure, before also we had seen this figure when we had studied the topic of current flowing through a wire. You have seen there are a large number of free electrons in a conductor in a metallic wire, and as I have told you, when the two ends are not joined, the conducting wire is not connected to the cell, what happens? These free electrons are always in a state of random motion. When a potential difference is applied between the two ends of the conductor, we had seen that the electrons being negatively charged, they start moving from the lower potential end to a higher potential end. This directional flow of electrons or the motion of electrons, it causes the flow of current. All these things we are just recollecting, which we have studied before. And in the movement, in the random motion of these electrons, they strike the atoms and the ions which lie in their path. See, if immediately something is announced in the class, now 5 minutes only you are going to get the recess, so hurry up. What will students do? They will just move out of the class. I am not speaking about the pandemic time, I am speaking about general situation. And while running, you are going to collide with each other, you are going to collide with any things which are there in your path, means you are not going to look here and there. So similarly it is with the electrons. When they move, in their movement, they strike with the atoms of the wire, they strike with the ions. Now you know that it is the conductor or the metallic wire. So the ions of that particular metal, maybe it is copper, maybe it is aluminium, so that ions will also be there. So when they are moving, they will collide with the atoms and ions. And what will happen due to this collision? Suppose you collide with anything, naturally your speed is lowered. So similarly happens here with the electrons also. Such collisions cause hindrance to the free flow of electrons and oppose the free flow of current, and this hindrance is called as the resistance of a conductor. So the property of a conductor due to which it opposes the flow of current is called as resistance and denoted by capital R. So now you know what is actually the resistance of a conductor. Our next small topic, you cannot say a topic, a small derivation on resistivity. Just now we have studied resistance. Now resistivity is nothing but a property of a substance. So if you want to speak about resistivity, at a given temperature, the resistance R of a conductor, it depends on the length L of the conductor, area of cross section A, and also the material it is made up of. So if the resistance of the conductor is R, then R is directly proportional to L, means resistance of the conductor is directly proportional to the length of the wire. So and inversely proportional to area. So R inversely proportional to A, you can say 1 upon A. So R is, you can say, proportional to L upon A. And if you want to remove this sign, so you have to take some constant, and this constant which is taken here, it is not small p, it is a small symbol, you can say in science, it is called as rho. You say rows and columns. So this constant is called as rho. So this rho, it looks like small p. So R is equal to rho L upon A. Rho is the constant of proportionality and it is called the resistivity of the material. And resistivity is a specific property of a material, and different materials, they have different resistivity. Unit of resistivity is ohm meter. Unit of resistivity is ohm meter and is denoted by this symbol. So resistivity of some materials I have displayed here. Resistivity of copper is 1.7 into 10 raised to minus 8 ohm meter. Nichrome, it is 1.1 into 10 raised to minus 6 ohm meter. Diamond is at 1.62 into 10 raised to 13 to 1.62 into 10 raised to 18 ohm meter. Now these things will not be asked in the exam. It is only for your additional knowledge. This derivation is important. What is resistivity? It is the specific property of the material. Is it different for different materials? Yes, it is different for different materials. What is its unit? Its unit is ohm meter. What is its definition? Resistivity is the resistance of a conductor of unit length and unit area of crossing. All these things you have to remember. Our next topic is electric circuit. You know about the different types of circuits which you have in your houses. So what is this electric circuit in scientific terms? First we will see its definition. A continuous path of an electric current through a conducting wires connected to the two ends of a cell and other resistances is called an electric circuit. Now here you can see a circuit is depicted by a figure. This figure, it shows how different components are to be connected in the circuit. Anyhow you cannot connect. Voltmeter you can see in parallel. You cannot put the ammeter here in parallel. So there is a specific, you can say, sequence in the connection of all these components. And this figure here you can see, it shows how different components are to be connected in a circuit by using the specific symbols for each of the components. And such a figure is called an electric circuit diagram. Now here in this figure 3.5 you can see an ammeter. Now how this ammeter and all is denoted, you are going to see in the next chart. It is used to measure the current. Ammeter, current is measured in amperes, and ammeter, which is connected in series, is used to measure the current. A voltmeter is used to measure the potential difference between the two ends of the resistor. So you can see electric cell, resistance, ammeter, voltmeter, and all these denominations you can see in your textbook in the next page, page number 36. The components, the names of the components, pictures. This is very important. The symbols which you are going to use in place of the picture while drawing the scientific circuit diagram, and what is the use of that particular component. Now here I would like to just tell you that this table, entire table which is there on page number 36 is important, as you require the symbols for adjusting in the electric circuit, but that part is removed out from the syllabus last year, and hopefully we are going to get the same reduction this year also. So don't stress more on it. Only the main thing you remember is what is the symbol of that component and what is the use. Even if it is a reduction in your syllabus, then also if you don't know the symbols and its uses, then it will become very difficult for you next year while you have to set up the electric circuit. So in short, we are going to see fast. Electric cell, this is the symbol with the positive and negative terminal. Use it to apply a potential difference between the two ends of the wire. Battery is nothing but a collection of number of cells. So you can see the number of cells have increased with a positive and negative terminal to apply a larger potential difference. If you want to apply a small amount of potential difference, a single cell is enough. When large amount of potential difference is to be applied, then a number of cells have to be connected, which is known as battery. Open tap key or the plug key, this is the symbol to stop the flow of current flowing in a circuit by disconnecting the two ends of the wire. Closed tap key or the plug key, this is the symbol to start the flow of electric current in a circuit by connecting two ends of the wire. You this everyone know, conducting wire to connect the various components in the circuit. Crossing wires to show wires which cross but they are not connected with each other. Light bulb to test the flow of electricity. If the bulb glows, if it is lighted, then the current is flowing. If the bulb doesn't glow, then it is not flowing. Resistance to control the flow of current in the circuit. Variable resistance to change the resistance as required and thereby control the current. You can see the same symbol here, only one small arrow, slanted arrow. Ammeter, I have already told you, a small circle with a positive and negative terminal with a capital A in between, measure the current flowing in the circuit. And voltmeter, same, only inside the circle you have capital V to measure the potential difference between the 2 points in a circuit. This all you can say not symbol, pictures you can just go through, because when we are going to do the Ohm's Law experiment in the lab, this all pictures I will show you in the video, practical video. So at present you only focus on the symbol and its use. Later on when we get the reduction in syllabus, this part will move out, but as your knowledge part, symbols and the uses should be known by you. So with this we wind up with our today's session. Whatever we have studied today, this physics chapters, as I have told you in the beginning, majority of the concepts are imaginary. So more and more when you go through the concepts, then only they will be firmly fit in your brains. And physics is linked with each other if you take science in the higher standards. In the next year also 10th standard, you have the chapter on electricity. So don't take this chapter in a very lighter way. More of the reading part, more of the numerical examples, all the formulae should be studied by you, and they should be, you can say again and again, revision is required on a regular basis. Till then, thank you from my side about the practicals. I have informed you everything in the live session. So keep your journals completed. Notebook completion also I have told you. I am going to check your notebooks online. Those who are not attending the session, it is for them. Coming Friday, I am going to check your notebooks online. So be present for the session, otherwise you will lose your marks. Thank you, dear children.